Continuing on with the section of chapter 1.5 on multiplying polynomials, if you look at the example for the background information, x3 times x to the second power, notice how x3 is laid out as 3x's, and x to the second power is laid out as 2x's. By visually looking at the x's, notice that you have 5 x's together, so therefore you write x to the fifth power, because you add up all the x's. So the same thing can be done with 3 to the fourth times 3 to the fifth. 3 to the fourth is laid out as 4 threes multiplied by 5 threes. That's going to take a while if you were to multiply those numbers out. So to condense the multiplication, you lay out the threes so that you have 4 threes and you have 5 threes, and you add those exponential values together. You have 4, 5, 6, 7, 8, and 9. So therefore you write 3 to the ninth power. So regarding the homework, we can discuss more about the multiplications of polynomials. So I'm going to edit this so that we have a little bit more information on how to work out the problem. For number 1, 3a6b3 times 8a4b3. If you look at the coefficients, 3 and 8, multiply those two together, you get 24. a6 times a4, that's as if you have 6 a's and 4 a's, so you have a6 plus 4. And a6 plus 4 is a10. And I'm going to drag the 24 down. The b's. b3 and b3, that's as if you have 3 b's and 3 b's. So if you lay those numbers out, or in this case the b's, then you're going to have 6 b's together. Seven xy3 to the second power. Careful. Multitude of students will drag the 2 to all the terms. Sometimes that can be useful, but most of the time it's not, because regarding the organization of the polynomials, you have to actually duplicate this twice. So duplicate. So 7xy3, 7xy3. And going to put this in parentheses just for organization. And again, just like with question 1, we're going to multiply the inside together. Be careful, 7 times 7 is 49. If you look at the x's, that's x to the first and x to the first, because it's the number of x's that you see, and there is only one x for each of the parentheses. So as an in-between step, please show that you have 1 plus 1 for x. I know this is a little bit redundant, but it will be useful by the time when you work with higher polynomials. And then you have y3 and y3. So that's, as an in-between step, you have 3 plus 3, and 3 plus 3 for y is y to the 6. 49x squared, y6 is your answer. Number 3. Again, since there's a power 2, that means you have to duplicate what's inside the parentheses twice. So I'm going to put this in parentheses twice and rewrite the 4c5. Don't forget the negative. And now, multiplication. 4 times 4, 16. As an in-between step, I'm going to write c, circle the 5. That's 5 plus 5. You're going to put the negative. c, 5 plus 5 is c, 10. So negative 16c10 is your answer. Seven, you have the power 2. The power 2 tells you that you're going to duplicate the a plus 4 twice. So I'm going to duplicate that twice, to put two parentheses. A plus 4, A plus 4. Since you have two terms of this parentheses and you have two terms of that parentheses, we're going to FOIL. F-O-I-L. FOIL first. A times A to the second. The second term, the outside, the A times 4, which is 4A. The inside term, 4 times A, so that's plus 4A. And then you have the last, 4 times 4, which is 16. So you have A to the second plus 8A plus 16. Because all I did was add like terms to give me this result. 8 is a little bit different since we're dealing with two terms in the first parentheses and three terms in the second parentheses. So you have to be careful when it comes to the distribution process. We're going to distribute y to the three terms inside. And after that, we're going to distribute the -2 to the three terms. So let's focus on the red first. Y times y squared is y3. Y times -3y is -3y squared. Y times 1 is plus y. Now for the blue. -2 times y squared is -2y squared. -2 times -3y is positive 6y. And -2 times positive 1 is -2. It looks a little bit messy, so let's add like terms. Don't forget about the negative. It's y3 minus 3y squared, but the minus can be interpreted as a negative. So -3y squared minus 2y squared. That's -5y squared. You add 3 and 2, which is 5, but keep the negative. Y and 6y. There's a 1 in front. 1 plus 6, that's 7. Everything else, they don't have like terms, so you're just going to keep them as is. That's -2, and this is a y3. Now, parentheses do matter when it comes to questions like number 9. If the parentheses was in between the 4a plus 5, then you would have to FOIL. Because 4a plus 5 and 3a minus 4 are separate entities. So you have to distribute each single part of 4a plus 5 to each single part of 3a minus 4. But that won't be the case. The number 5 is attached to the parentheses of 3a minus 4. So I'm going to distribute 5 to 3a and -4. 5 times 3a is 15a, and 5 times -4 is -20. And I'm going to rewrite 4a. Combined like terms, I see that we could combine 4a and 15a, so that's 19a. And this is -20. Number 10. Again, 5y is mixed in with the 3y minus 4, and -6 is mixed in with 3 minus y. So I'm going to distribute 5y to both terms inside, and you're going to distribute the -6, and I'm careful, I'm keeping the negative. It's okay if you want to work with the 6, but most of the time students will forget to re-include the negative sign. So it's best to use 6 as -6 to distribute to both of the two terms. For the red marking, 5y times 3y. 5 times 3 is 15, y squared. 5y times -4 is -20y. Now for the blue marking, -6 times 3 is -18. -6 times -y is positive 6y. So be careful about your signs. Add like terms. I see that there's a y here, there's a y there. So we're going to do negative 20 plus 6, which is negative 14. I don't see anything else that we can combine together, so everything will be rewritten as is. Eleven is a little bit tricky, but if you can understand the rules of the exponents, then as long as you're following the rules properly, then everything should work out. The power of 3. The power of 3 tells you that you're going to duplicate z minus 3 3 times. So I'm going to put 3 parentheses. I'm going to put z minus 3, z minus 3, and z minus 3. And we're going to FOIL the first two. Z times z is z squared. Z times negative 3 is negative 3z. And for the second term, negative 3 times z is negative 3z. And negative 3 times negative 3 is positive 9. Combine like terms. It's negative 6z. Rewrite everything else. Plus 9, z squared. We're still not finished. We still need to distribute the 3 terms of this to z minus 3. Z squared times z, so I'm going to put an arrow here. That's z to the third times negative 3z squared. And I'm going to erase the markings so we can work with the negative 6. Negative 6 times z, so that's negative 6z squared. Negative 6 times negative 3 is positive 18z. And I'm going to erase the arrows. And now the next number to work with is 9. 9 times z, 9 times negative 3. That's positive 9z minus 27. Combined like terms, I see that we can combine negative 3z squared and negative 6z squared. So that's negative 9z squared. z3 will be rewritten. I see we can combine 18z and 9z, so that's plus 27z. And negative 27 is by itself. There are no other like terms, so we're just going to keep it as negative 27. So the answer is z3 minus 9z squared plus 27z minus 27. On the next video, I'll be discussing questions